Displacement. Displacement is a vector quantity that refers to how far out of place an object is. It is the object's overall change in position. In the picture to your right, we can see the displacement as the green dotted line. Also, in calculation, the letter S is given for displacement. In the example that we provided is 6t squared minus t to the power of 3. Velocity. Velocity can be defined as the distance covered by an object in unit time. Velocity can also be defined as the displacement of the object in unit time. In the example that we provided is given by the red car on the picture below. This car traveled 10 meters in 5 seconds. So we can get the velocity of this car by using the slope formula, which would be 10 minus 0 over 5 minus 0. And the answer is 2. So the velocity of this car is 2 meters per second. Also in calculation, the letter V is given for velocity. In the example that we provided is 12t minus 3t squared. Acceleration. Acceleration is defined as the rate of change or derivative with respect to time of velocity. Acceleration can also be seen in a simple way as the change of velocity over time. And we can see this phenomenon on the picture below, especially on the yellow car. This car is going to pull the brakes, which means that it's going to slow down little by little until it finally stops on an infinite point. That's why its velocity is going to be minimal but positive still. Meanwhile, its acceleration is going to be decrementing little by little until both of them, its acceleration and velocity, reaches 0. And finally, the relationship between displacement, velocity, and acceleration is quite simple and easy to understand. For instance, the derivative of displacement would be velocity, and the derivative of velocity would be acceleration. And this process can also be inversed, which means that the integral of acceleration would be velocity, and the integral of velocity would be displacement.